Hello! So I posted a link to my previous video on the Arduino subreddit, and Doodleflaps, which is a really cute name, said that they were planning to use a similar module for drum samples, and they wanted to know if the response time was 12 milliseconds or less. And that got me thinking about how we could measure this. Now I want to test both MP3 and WAV files, and also triggering the sound by pulling one of the trigger pins to ground, but also triggering it over the serial communication port using the library I wrote and posted about in my previous video. Now I'm not going to use the busy pin on the device to tell me if it's actually playing the file. I'm not sure if it reports that it's busy as soon as it receives the command to play the file or after it actually starts playing it. What I'm going to do is I'm going to be monitoring using analog read one of the speaker pins on the device. So as soon as that actually starts making a sound through the speaker, I should see a spike in the voltage on that pin, and that's when I'll know that it's actually started playing. So after writing the code, I fire up Audacity, and I just create a simple file that just has a single tone in it, which ensures that the very beginning of the file is actually generating some noise. Just doing some testing with the code here and correcting a couple of small typos. And here we have it running. So whenever I press reset on the Arduino, it waits 1 second, sends the command by pulling the pin to ground, and then starts monitoring the analog read, which you can see as all those very low numbers. And then as soon as it sees that spike, it records the time. So I tested that with the WAV file, and then I created the same file as an MP3, copying that over now, and then rerunning the test now with the MP3 file. This first run is pulling the first pin to ground, which then plays the file numbered 001. So with those results in, I went back to the code and I inserted my library. So instead of pulling the pin to ground, what I'm doing now is I'm telling it over the serial communications to play the file number 1. And now with the code uploaded, resetting the Arduino does exactly the same, but now it is telling it to play the file over the transmit and receive pins. And with those results in, I connect the device and upload the MP3 file. Because I'm communicating over serial this time, I can upload the file as 002.mp3 and modify the code to alternate between playing the WAV and the MP3 file. Another advantage of using the library. So I re-upload the code now with the play file changed to play file number 2, and reset the Arduino 3 times to get my results. So here are the results. I tested both WAV and MP3, both driving the pin to ground and also communicating over serial. The 3 different attempts, and then the average values are here. So as you can see, WAV is quite a bit quicker in both cases than MP3. But what's interesting is that serial is quicker than driving one of the pins to ground, which I wasn't expecting. So there you go, the quickest way, or the way with the shortest delay, is to use serial and WAV files, and that gets you an average response time of 59.7 milliseconds. Thanks for watching.